Alrighty, let's talk about sets. So, a set is just a collection of elements, and elements can really be anything. They could be numbers, they can be letters, sequences, strings, anything really. So, a set looks something like this. It's in curly braces. Every element is just going to be separated by commas. You can have letters, anything you want, any objects you can think of. Sets can also have sets within them. So let's say set C has set 1, 2, 3, or set 1, 4, 5, whatever you want, really. And basically, that's just how you draw them. You could also have a set that looks something like this. It's just a different way of writing it. And let's say someone tells you all elements X are part of the set that contains all the integers. So X has to be an integer and it has to be greater than 10. So this little line just means X such that X is greater than 10. And that's what A is going to be. So A would look something like this. 11, 12, 13, and so on, right? So that's just how you denote a set. Now there's a few symbols that you need to know when you're doing sets, and one of the most important things you need to know is this little symbol. It looks like an E, and all it really means is in. So if I say X is in A, that just means technically X is inside A, right? But usually when we say this, we mean an arbitrary X, and then we define what this X can be, just like the other situation where our set A had X such that X was greater than 10. A didn't actually have the letter X, but we're just using X as an arbitrary variable, sort of. So that's all that E, or this little symbol, means. Another important symbol in set theory is subset and proper set. Subset, proper set. So a subset is just a set within another set. So let's say X is in A. If X is in A, then X is in B. So anytime you have something in set A, that something also has to be in B. So let's say A is 1, 2, 3. Then B has to have 1, 2, 3, right? It has to have all these elements. So since it's just a regular subset, not a proper subset, it has this extra little symbol here. And you can think of it as like an inequality, less than or equal to. So it could also be equal to. So you can either have, oh, sorry, missed this setup. So you can either have 1, 2, 3 in B, or, so this will be equal, right? A equals B. Or you can have a few more, or however many more you want. So when we say A is a subset of B, it can either be equal to B, or it can have everything inside B, but B might have some more stuff that A doesn't have. So when we see a Venn diagram of this, it would look something like this. That's a horrible square. Just ignore that. Let's say we have B. A would be inside, right? Because everything in A is in B. Or alternatively, you can have them equal to each other, and in that case, it would just look something like this. They would kind of just be overlapping. So both circles would just be there, equal to. Now, a proper set is the exact same thing, only you can't have this situation. This is not allowed. So it's the same definition. If X is in A, then X is in B. But there exists a Y or another thing that's not X that is in B, but Y is not in A. So let's write there exists here. So in this situation, this is allowed, but the other situation of 1, 2, 3, 1, 2, 3 is not allowed. So A cannot equal B, right? So when we do a Venn diagram, it's the exact same thing as our first scenario that we had, but this first scenario is the only thing allowed. You can't have them overlapping anymore. Now, we also need to talk about intersection and unions. So, an intersection looks like this. This is the symbol. So if we say A and B, assuming A and B are sets, then that just means if, I'm sorry, no if. This just means X is in A and X is in B. So if we have set A equal to 1, 2, 3, and set B equal to 1, 5, 6, the intersection of the two would be what they both have, the element that's in A and in B. So when we make this set A and B, we should get only the elements that are in both A and B. And in this situation, the only elements that we have the same would be 1. And if we were to do a Venn diagram showing this, it would look something like the, oh wow, that's a horrible circle. Okay, so A, B. So A would have a 2 and a 3 here. B would have a 5 and a 6 here. And then the 1 would kind of be in the middle, right? So A and B would just be the intersection of the two. So it would just be this one, and we'd color it in right here in the middle. Now a union is the opposite. Intersection was this way. Union is this way. A good way to remember is just union. U looks like a U. So a union just means X is in A or X is in B. So if I have A is AB and B is 1, 2. A or B is going to be so if I'm saying X is in A or B, then X could either be AB or X could be 1, 2, right? So A or B will just be everything because it's either in A or it's in B. So that's going to include everything. So when we do the Venn diagram for this, it's going to look something like this. Well, in this situation, they don't overlap. So let me just add some more stuff just to make it look a little more complicated so I make sure you really understand. So let's just say we had a little bit of an overlap because 1 was here. So we'd have something like this. They could be separate, of course. But A or B would just be A or it would be B. Now, I forgot to mention something about sets. Sets never have duplicates, so that's why we're not going to write 1 2 times. And sets are the same no matter what order. So set A, B, C is the same set as C, A, B. So it doesn't matter the order, and set A does not exist. You can't have the same elements 3 times. Just a little side note there.